In this gas stoichiometry problem, we are going to use both the ideal gas law and a BCA table. The problem reads, the safety airbags in automobiles are inflated by nitrogen gas generated by the rapid decomposition of sodium azide, NaN3. According to this reaction, 2NaN3 yield 2Na plus 3N2. If an airbag has a volume of 32 liters and is to be filled with nitrogen gas at a pressure of 1.4 atmospheres at a temperature of 24.0 degrees Celsius, how many grams of NaN3 must be decomposed? Because this question is asking for grams of a substance that is not the gas, we first have to use the ideal gas law and then use that number to plug into our BCA table to solve for the amount of sodium azide that we started with. So we're going to start with our ideal gas law, which is PV equals nRT, and we are going to be solving for N. The pressure given is 1.4 atmospheres times a volume of 32 liters is equal to N, what we're solving for, times R, the ideal gas constant, 0.0821, times temperature. A reminder that temperatures must be in Kelvin, and we were given 24.0 degrees Celsius, so we need to add 273 to get a total temperature of 297 Kelvin. When you do this and solve for N, you will get 1.84 moles, and that is moles of N2. It must be the moles of the gas because we use the ideal gas law. Now we're ready to create a BCA table. Reminder when you're starting your table that your products always start as 0. And the beginning number, the number in the before section for the NaN3, that is the number that we are looking for. That's what we're trying to solve. We were given 1.84 moles of N2. That's the number we solved for already in our ideal gas law. So in our BCA table, that goes in the after row, 1.84 moles. We can work this problem backwards to solve for the amount of NaN3 that we must have started with. If we know we had 0 moles of N2 to begin with and we ended with 1.84 moles, we know we must have made 1.84 moles. Because the coefficients are different, we need to cross multiply to figure out our other values. So we'll set up 3 over 1.84 is equal to 2 over x. When you solve this cross multiplication problem, you should get x is equal to 1.23. And we can fill that in for our other two change numbers because both Na and NaN3 have coefficients of 2. Then we can just complete the problem. We know we should always end up with 0 of our reactant, which means we started off with 1.23 moles of NaN3. Now when we look at the question, it asked for grams of that substance. So we need to do a one-step conversion from moles to grams, and we use the molar mass of NaN3 to do this. So in 1 mole of NaN3, there are 65 grams. And then when you complete this calculation, you should get a final answer of 79.95 grams of NaN3.